Okay, so today we are going to look at some more integral examples that when we integrate, we're going to get ln. So this example is a little bit different than the ones that we've looked at before. We're integrating x squared plus x plus 1 divided by x squared plus 1 dx. Okay, so here's what's different. If you look at the degrees, which means the exponents in the top and the bottom, they're the same. Since the degrees are the same in the numerator and in the denominator, we need to break up the equation by dividing. So yes, this does mean polynomial division, so you have to be careful. You probably haven't done that in a long time. Okay, so what that looks like is that the one on top is being divided, so we will have x squared plus x plus 1 divided by x squared plus 1. So polynomial long division, you take the first two terms, so we have x squared and x squared. What would we multiply x squared by to get x squared? Well, they're the same thing. There's no difference, so you would multiply by 1. Then you would distribute this back down. So we're going to take the 1 and we distribute here. So we'd have x squared. 1 times x squared is x squared. 1 times 1 is 1. So we're going to line that up under the same, the common term. So we don't want to put it under x because we won't be able to divide x and 1. So our next step in long dividing is subtracting. So we subtract both of these. So x squared minus x squared cancels. 1 minus 1 cancels. And we have x left over. So we have plus x over what we divided by, so plus x over x squared plus 1. So that's how we break up this integral. So it becomes the integral of 1 plus x over x squared plus 1 dx. Okay, then from there we can split the integral up. So we can do the integral of 1 dx plus the integral of x over x squared plus 1 dx. Okay, then we can integrate 1. Okay, we just use our regular integral rules. But over here, we have an x squared plus 1 in the bottom. So we will need u substitution here. So our u is on the bottom, x squared plus 1. And du is 2x dx. And then we can substitute that back in. Remember, it's just going into this second one, so we'll leave the first one alone for now. Let's not integrate yet. This is the integral of 1 dx plus the integral of du is on the bottom, so u is down here because x squared plus 1 is u. And then 2x dx, that means we need to put a 2 in here, so we also need to divide by 2, so we're going to have a 1/2. And the 2x dx turns into du. And from here we can integrate. So this one we are integrating with respect, we are integrating with respect to x, and the other one we're integrating with respect to u. So be careful here. The integral of 1 dx is x, or 1x, plus we have 1/2. 1 over u is the ln of what's on the bottom, so absolute value of u plus c. And then we can just put the x's back in to here. So u equals x squared plus 1. So our final answer, when we simplify all this, we have x plus 1/2 ln absolute value of x squared plus 1, close your absolute value, plus c. So there is our answer for this problem.